Hello, good morning to all of you. Today we are going to start redox reaction. So basically, what is redox reaction? In our nature, there are several type of reactions. Few are addition of oxygen or removal of hydrogen, or addition of hydrogen and removal of oxygen. But not all the reactions are in this category. Means if there is no change in oxidation state, if oxidation state remains same in the reactant and product side, then it is not considered as a redox reaction. But in case of neutralization reaction or nuclear reaction, it do not come in this category. So let us take an example of neutralization reaction first. So neutralization reaction. What is neutralization reaction basically? It is a acid-base reaction. Let us take any acid. We are taking king of chemicals, that is H2SO4 with a base. Base we are taking 2 moles of NaOH. What will it form? It will form Na2SO4 plus water. So in this reaction, we can find out here hydrogen is in +1 oxidation state, oxygen it is in -2, and sulfur is at +6 oxidation state. In case of Na+, sodium is Na+, oxygen -2, hydrogen +1. So these are the concerned oxidation state of the elements. Let's find out in the product side. In the product side, sodium is +1, sulfur is +6, and oxygen is -2. Hydrogen +1 and oxygen is -2. So we can clearly see there is no change in oxidation state either in reactant side or in product side. So we will not consider this reaction as a redox reaction. So this is basically a non-redox reaction. In case of nuclear reaction, it follows Einstein's rule, that is E equal to mc square. This is mass energy conservation rule. Or in this case we can say it does not follow this rule. Why? Because element do not exist in form of that element. Here mass is transferred to energy. This is also known as mass energy equivalency. Coming to the next part. So we are reading oxidation state while explaining neutralization reaction. So basically what oxidation state is? What is oxidation state? Let's find out. So oxidation state. We can say that is charge present or appears to be present in the combined state of an element. In the combined state of an element known as oxidation state. So what does it mean? Charge present or appears to be present. Let us take an example to understand it. So in case of charge present or appears to be present, I am taking one example, that is HCl in gaseous state. In gaseous state, we know it is a covalent compound. So hydrogen, it is delta plus, and chlorine, it is delta minus. How can I know that hydrogen will be positive or chlorine will be negative? There is a simple shortcut to understand this. We will follow this rule. Phone call SP. This is the electronegativity order. Fluorine is most electronegative. Electronegativity near about 4.0. Oxygen 3.5, nitrogen 3.49, chlorine 3, sulfur 2.8, and phosphorus is near about hydrogen 2.6. Hydrogen is 2.5 generally. So, in this case, by knowing this, we can say which one is more electronegative, which one is less electronegative. As chlorine is more electronegative than hydrogen, it will attract its electron cloud towards it. It will attract the electron cloud of hydrogen actually towards it. So what is happening basically here? Chlorine is getting delta negative, means very small negative charge. Hydrogen is very small positive charge. If we take HCl in aqueous medium, what will happen? It will be H plus aqueous plus Cl minus aqueous. Here we can say, in this case, charge present here appears to be present. So, a common confusion comes in students. We have seen a common confusion regarding oxidation state. So, basically they ask that formal charge and oxidation state are both same or different. What happens? In case of oxidation state, charge or electron is not mutually shared. In case of formal charge, it is mutually shared between two atoms. So when we try to find out the formal charge, we know formal charge is an imaginary charge. But here we find out that charge electron is being shared from one atom to another. There is no mutual sharing. So this is the basic difference between formal charge and oxidation state. Now taking few more examples to understand it better. We are taking oxides of carbon. So what are the oxides of carbon? Oxides of carbon. Basically, carbon has two types of oxide. One is acidic oxide, another one is neutral oxide. So what is acidic oxide here? CO2, carbon dioxide, is considered as acidic oxide. In case of neutral oxide, we find out C3O2, carbon suboxide and carbon monoxide. These are neutral oxides. One question came in NEET regarding C3O2. It was asked, what is the oxidation state of the central atom of carbon in carbon suboxide? So how can we solve this? Let's find out. Let us take C3O2. So, there is few basic rules for drawing any type of structure. What are the rules? Oxygen, fluorine, hydrogen are generally not the central atom. Central atom will always be less in number, and in maximum of the cases, second highest electronegative element. Third case we can consider, we will try to give maximum valency to the central atom. If oxygen is only present, we will connect it via double bond. If oxygen is present with hydrogen or any alkali metal, what are the alkali metal? Lithium, sodium, potassium, rubidium, cesium and francium. Atomic numbers 3, 11, 19, 37, 55 and 87. These are the respective atomic numbers of the elements. So in case of C3O2, we are going to find out. For that we need to know this. So if oxygen is present with alkali metal or hydrogen, what will happen? We will keep hydrogen or alkali metal in the terminal position like this, and we will find out the oxidation state. Now let's see in case of C3O2. Carbon connected with carbon, connected with carbon. Only oxygen is there, so we are going to connect it via double bond. So let's see. Carbon and oxygen we will consider at once 2. So carbon and oxygen, 2 bonds are there. Oxygen negative, carbon positive. 2 bonds, so -2. This is +2. This carbon is also connected, but it is the same atom. At same atom, there is no change in electronegativity. So we are going to get 0 for this. This is also getting 0 for this carbon also it is getting 0. This is plus 2, this is minus 2. So for the central carbon atom, oxidation state is equal to 0. Let's find out for CrO5. It has butterfly structure, very beautiful structure, deep blue in color. In case of CrO5, this is our CrO5. So this is deep blue in color. In case of CrO5, we can find out 2 bonds, 3, 4, 5, 6. So chromium is at plus 6 oxidation state. Here oxygen connected with oxygen, single bond, means it is a peroxy bond. We consider that oxygen single bond oxygen is considered as peroxy bond, but it is not completely correct. If oxygen connected with oxygen and that part is connected with any electropositive element, this side also any electropositive element is there, then only we consider that this bond is peroxy bond. Let us take an example for F2O2. In case of F2O2, what happens? Fluorine, oxygen. In this case, oxygen is plus 1. So we will not consider this bond as a peroxy bond. So now we will go to the next part, oxidation number. So basically, what is the difference between oxidation state and oxidation number? Let's find out. Oxidation number is nothing but the average of oxidation state. There are two ways to find it. We have find out for C3O2 oxidation state. Now we are going to find out oxidation number as well. So in case of C3O2, let's see. This was the structure of C3O2. Here we have find out that carbon is 0. This is plus 2. This is plus 2. So average of oxidation state or average of charge. So plus 2 plus 0 plus 2 by 3. So its oxidation state is plus 4 by 3. Or another way is there. We are considering carbon as X. So 3 carbon, 3X. General oxidation state of oxygen is minus 2. 2 oxygens are there. So 2 into minus 2, that is 0. So X is equal to plus 4 by 3. By this way we can find out. In many books it is told that oxidation state and number are same. But it is not completely correct. If we get in case of CO2, this is the structure of CO2. Here oxygen minus 2, this is plus 2. This is minus 2, this is plus 2. In this case, oxidation state equal to oxidation number. Why? Because only single type of atom and only one atom is present. If more than one atom present of same type, we will take the average. Otherwise, if only single atom is present, then only we can say that oxidation state is equals to oxidation number. I hope you understand the topic well regarding oxidation state and oxidation number. So thank you.